This is the electromagnetic spectrum. At first glance, it looks like a calculus on sketch, but really, if you take a close look at it, you can see that it's actually made up of almost all wavelengths of radiation that we can actually see. And this is how scientists are really interested in seeing how electromagnetism actually works. So today, I'm explaining how the electromagnetic spectrum works and how you can really enjoy it. Let's go. So I'm going to break it down into the absolute basics. So electromagnetism is basically made up of two words, electrons and magnetism. So it's just the relationship between electrons and how they interact with one another inside a magnetic field to produce charges. Now let's start off with the beginning of the spectrum, radio waves. So radio waves are found almost everywhere, even in space, even your radio frequency you listen to BBC on, and also even your TV. Now next we have the microwave. Like typical microwave, for example, the one you use at home. The thing is that microwaves have energetic particles, but then they're not ionizing, which makes particles in the microwave relatively safe. So it's just heat that's being generated from the kinetic energy of the particles, which makes the food hot. So yeah, microwaves are very safe. Unless your microwave is faulty, that's when the real problem comes. Then we also have microwaves in astronomical terms and scales. So we have something called the cosmic microwave background. It's also called cosmic microwave background radiation, also known as CMBR. So it's just the amazing glow of matter in space of which you can actually see through. So that was microwaves, but now let's move on to something a little bit higher on the spectrum. We have infrared, which means below the frequency of which we can actually see. It's just a notch below visible light. So infrared is basically, thermal radiation being detected. So if you look at a very bad picture of me I took earlier, of me right here, this is so inaccurate, but yeah, it gives you an idea of how infrared radiation actually works. But then usually in everyday times, your TV remote shoots out infrared radiation to your TV to collect it. So radio waves and infrared waves kind of work together at that point. Now we have something called visible light. 7 colors of the rainbow, Roy G. Biv, what we call visible light. Fun fact, we can actually see 1,700 colors as humans, making us one of the most prominently dominant visionaries of the universe. Yeah, I made that pun on myself. But now let's move on to the more dangerous form of radiation. This is what we call electromagnetic rays. So now let's move on to what we call UV rays, also known as ultraviolet rays. So it's basically incoming radiation from the sun. Now if you know sunscreen, it actually just filters ultraviolet radiation. Now we have something called the ozone layer, which actually deflects and absorbs ultraviolet radiation and deflects it back into space. So that's what the ozone layer is for, and humankind depletes it. Wow, so ungrateful. So the sun is basically the main source of ultraviolet radiation and is extremely dangerous in very large quantities. But what's more dangerous? Well, X-rays. So X-rays, which is one of the most powerful forms of radiation on the EMS, electromagnetic spectrum. So these are used for doctors. Doctors use X-rays to look at your bones because it actually penetrates through your skin as imagery, not as ionizing radiation. That's the difference between X-rays from nuclear wastes and also from the sun, and also X-rays used in doctorates. So the doctors use X-rays to look at your bones, but also the sun uses X-rays to mainly shatter planets. For example, an X-ray flare is a very dangerous event where magnetic field lines on the sun reconnect and then they form a lot of energy and bursts out into the universe's vacuum. So X-rays are mainly found here on Earth, but then even in space, a lot of X-ray radiation is found there. But then that is second to one, which is gamma rays. Gamma rays have the shortest and fastest wavelengths, but also they don't have ionizing power, which is a very huge topic. Ionizing power is basically when the energy is very high, but then it also has very low penetrating power depending on what kind of particle we're talking about. For example, alpha particles, beta particles, they have ionizing power, but then because they are not electromagnetic, that means gamma rays have a much lower ionizing power. In fact, they have zero ionizing power. They have a zero mass, zero charge, and they have the highest penetrating powers in the entire electromagnetic spectrum. So gamma rays are mainly found in gamma ray bursts from nearby stars, quasars, black holes, and are very dangerous. So as long as you're pointed away from them, you are safe. So take the electromagnetic spectrum as the rainbow. There are mainly 7 wavelengths of colors. So you can take it in order from R to V. So red is radio, V is gamma, and then in between is the rest of the colors. So anyway, the electromagnetic spectrum was basically introduced a long time ago by this guy in this year. Yeah, it wasn't quite recent. But because there are many other forms of electromagnetism, well, in terms of the radiation types, some of them were not really included. For example, hydrogen alpha is actually found between visible and infrared, but then it's not really there because it's not typically used. So a lot of other particles and type of radiation are there, but then these are the 7 main types: radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma. So the shorter wavelengths are found at the right side, while the longer wavelengths and slower and less powerful are formed at the left side. So many other types of radiation and sources are there. For example, Jupiter. Jupiter has a lot of radiation. It basically has every single form of radiation. For example, even Earth. Earth has a lot of radiation also. Typically the Van Allen radiation belts, with a lot of radiation of mainly radio signals being emitted from inside the Earth. It's called dynamo action, but it's quite different from the magnetic field. But magnetic fields are a topic for another time, because magnetic fields are kind of interrelated with electrons. That's what become electromagnetic fields and electromagnetic spectrum, electromagnetism. You get the gist, right?
Nice.
So, electromagnetism 101, that was it on the EMS. So now you know, subscribe and like. Follow my TikTok, link in the description below, so we can talk about more facts about science, physics and geography that you never knew about. So, this is Joseph signing off. Peace.